and thank you for joining. So for today, we're going to do some recap, probably not into detail of what has been done so far, but the focus of today is actually going to focus on how to rename uh, variables, okay. Um, so the focus, so for today's focus, we're going to look at renaming variables. All right. We'll also look at variables labels. All right. Creating new variables. Then we're going to look at recording variables. All right. Then we're going to look at how to sort variables. Then we're going to look at how to delete variables. Then we'll look at merging. All right. So we'll look at merging and appending. All right. Then after which we'll do some descriptive and inferential statistics. All right. So this is going to be our today's focus. All right. So we're going to focus on how to rename variables, how to label variables, how to create new variables, how to recording variables, sorting variables, and how to delete variables. Then we're also going to look at merging and appending, and we're going to look at a brief on the descriptive and inferential statistics. All right. So as a way of recap, we're made to understand, and when we started in the day one, that there are two branches of statistics. We have the descriptive statistics and also the inferential statistics. And we also mentioned that there are three levels of research interest. Whenever we need to conduct a study, we mentioned that there is a study when our interest lies on the descriptive, all right? When we're trying to summarize our data set about which you cannot make an inference, but descriptive statistic, as it were, it helps us to be able to summarize our data set of the sampled population under consideration, all right? So a sample is a fraction of the total population under consideration. So when we are dealing with descriptive statistic, we are not making an inference and we are not testing for significance, all right? Then if that's our interest, then we can do some sort of frequency analysis. We can do some measure of dispersion, mean, mode, and the standard deviation. Then we can also do some graphics when it comes to the descriptive statistic. Then the second level that can also be of interest is when we want to find association or relationship between variables, all right? When we want to look at, is there any association or relationship between variables? Then in doing that, our interest might lies in running some sort of chi-square analysis, correlation, regressions, and what have you. Then lastly is when our interest lies in a difference between variables, all right? So when our interest lies in difference between variables, then we can now look at independent t-tests, analysis of variance, and what have you. All right. So these are three levels when it comes to research: descriptive, associational, and difference. All right. So even when you're going to formulate your hypothesis will have to be formulated around and testing for association or relationship between variables, or checking for difference between variables. And again, we also mentioned that there are also two levels of statistical techniques. We have what we call the parametric statistics and not parametric statistics. So there are different assumptions. All right, there are different assumptions and when a parametric test can be used and when a non-parametric test can be used. And we also mentioned normality tests. So when a data set follows a normal distribution, it shows that the statistical test that we conducted has to be a parametric test. All right. But when the data set does not follow a normal distribution, it means that an alternative statistical techniques of a parametric test has to be used. All right. Let's say, for example, if our interest lies in an association and we want to do, in difference, and we want to do a sort of a one-way analysis of variance. But if the data set we are using does not follow a normal distribution, then the option might be for us to do a Mann-Whitney test. All right. So a Mann-Whitney U test is a non-parametric equivalent of a one-way analysis of variance. All right. Then in the day one, we also mentioned that there are four classes when it comes to scale of measurement. All right. Scale of measurement is very important because it tells us about it helps us in choosing the appropriate statistical techniques that we need to use. All right. Then we have what we call the nominal, which of course can be the categorical data. We have what we call the interval, we have the ratio, and we also have the nominal, we have the interval, we have the ratio. Then the fourth one is what? Then we have the ordinal. All right. So for example, if your data set follows is a nominal on a nominal scale of preference, and we need to do a test, then we know that the appropriate test in an association might be a chi-square. For example, if you have two variables that follows a normal distribution of sex and education. So sex has two options of male and female, while education has three options of primary, secondary, and tertiary. So in that case, we can run a cross tabulation, which is chi-square, because that becomes a 2x3 cross tabulation. All right, because gender has two levels, male and female, 1, 2, and education has 3 levels, primary, secondary, and tertiary, and that makes it a 2x3 table. And for example, if your data set follows a continuous variable, for example, we have height and weight. All right, you want to check if there's a relationship between height and weight. Now, you're not going to subject your data to a chi-square because it does not follow. The scale of measurement is not nominal but continuous, as it were. So the appropriate statistic that needs to be used in that sense is correlation. All right. So which implies that understanding your variables in terms of their scale of measurement is very important in choosing the appropriate statistical techniques that we need to use for our analysis. Then lastly, we also mentioned different type of variables. All right, we talked about the discrete variables, we talked about the continuous variables, then we also talked about the dependent variables, then we also talked about the independent variables. All right, so all of these are very important for us to know the appropriate data and variables that we need to use in analysis. Let's say, for example, we want to do a regression analysis. Now, in doing a regression analysis, we have the simple regression analysis and also the multiple regression analysis. Now, your simple regression analysis in terms of regression line is when you have one dependent variable and one independent variable. All right. So which implies mathematically, it means your y, which is your dependent variable, equals to your beta naught. Your beta naught is the constant plus beta 1 x1 plus the error term. So the beta 1 there is a dependent variable. All right. Why your multiple regression is when you have one dependent variable and more than two independent variable. All right. And an example, for example, your salary might be your dependent variable. I want to understand what are the factors that are contributing to my salary intake. Are we together now? So which implies your level of education, your level of experience, your gender could be the dependent variable, all right, predicting your earnings in terms of your salary. So which implies that your salary becomes your dependent variable, while the explanative variables, all right, explanative variables is another word for dependent variable or predictors, is now your level of education, your gender, and probably your level of experience as a predictor of your salary. Another example could be a contraceptive uptake. All right. So contraceptive uptake could be defined as a dependent variable in the sense that, are you currently using contraceptive? All right. Are you currently using modern contraceptive? Yes or no? Then our interest might now becomes, what are the factors that determine use or not usage of contraceptive? So it could be distance, it could be cost, it could be health workers' attitude, it could be side effect, it could be religion, and what have you. So all of these, for examples, are examples of dependent variables. All right. So it's important that when you want to do a study, you need to understand all of this in detail for you to be able to tell the appropriate choice of statistic that you know is appropriate for your analysis. Remembering that garbage in, garbage out. All right. So if you pick different variables, as it were, in your status environment, it's actually going to yield an output. But what is important is, are you actually using the appropriate statistical techniques for your test? All right. So let me also move on very quickly. We also mentioned that there are two levels by which we can interact with our STATA environment. We said number one is when we use the menu and the dialog box. Okay, so these are the menu and the dialog box. When we have the menu bar, then and this, of course, for example, are the dialog box. All right, this is a dialog box, a summary, a summarized dialog box. And the second way we can also interact with the STATA environment is the use of the command. All right, the use of the command. Then thirdly is the use of the do file. All right. Then lastly, before I move on to what we need to do today, and I said that there are about 1, 2, 3, 4, 5 windows that you know in STATA environment. The number one is what we call the review window. All right. This takes stocks of past code, all right, past command for reuse. And this space here is what we call the result window. All right. Then the space here where you can say command is where we call the command window. While we have the right top hand side is what we call the variable window, and this side is what we call the property window. So all of this is important because we have some few folks that joined us today, and that is what necessitates the comprehensive recap that I've done. All right, so moving to what we have today. So I've actually shared the sample data set with us, and I also said to us, if we remember, that there are two ways by which we can bring in our data set to Excel, to STATA. Number one is by going through the file menu. So you click on file, then from file, you come to import. All right. Then you can now choose the type of file you want to bring into STATA. The secondly is by using the file, the data editor edits. All right. There are two. We have the edit and we have the browse. So the browse is to view and you cannot make an edit, but an edit is for you to be able to make inputs. All right. So Excel. That's what I'm bringing in. So this is the import Excel dialog box. Then I'm going to click on browse. Then I'm going to locate the file depending on where you have it. So this is my sample data set. Then I'm going to bring it in. Now, so you're going to see the preview of the data you are bringing in. Now, because you're bringing in an Excel file and not a CSV, then you need to check this box that says import first row as a variable name, and that is done. Then you can now see that the variable name moves up from the preview. Then we can now click on OK. All right, so we click on OK. So when that is done, you can actually view your data set by clicking on data editor browse. All right, then you can view your data set in that manner. All right, you can check and all of that. Then we close. Now, one thing that is also important is that the moment you bring in your data set, then you need to save your data set. All right, you need to save your data set as a STATA file. All right, in saving your data set as a STATA file, then we come to the menu, file menu, then we click on save as. All right, save as. Then I can save it as sample sample data again. Then I click on save. Now the extension of data file of STATA data file is .dta. All right, is .dta. Then I click on save. Cannot save it, choose another location. Okay, so document, I'm saving a document, then save. All right, so that is done. Now we can now see from here, this is the save directory in terms of where the data has been saved to. So the data is saved in data, and that is the data name. So when that is done, the next thing we need to do is that we need to start exploring our data set. Exploring our data set. Now I'm going to be using more of the command line than going through the menu. Now, one step in exploring your data file is to use describe. So the word describe is actually a command that gives a general description of your data set and the format of each of the variable type, all right, in the data set. Are we together now? So the word describe, all right, describe is a command in STATA that gives a general description of your data set, including the format of each of the variable, all right? So you simply type in describe. Please note that this is case sensitive. So when you're typing describe, this is actually all lowercase, all right? All lowercase. Then you click on enter. Then you have it. Let's say, for example, that you type in a capital D, describe, and press enter. You can see when you see any in your preview window, when you see anything in red, it means that there's an error in your command, and you now see a note, all right, that try to describe your I mean the error. So again, like I said, this is an history. Then we can still double click on it from this point, and we can type in enter. Top.
Yes, actually, I'm checking it now. And when I typed describe, what I'm seeing here is variable name ABCDEF. It's not showing the exact labels.
Okay, okay. So I think when you import your data, you did not check import file and import first line or something as a variable name.
Okay.
Yeah. So that's why you're showing ABC. So if you clear your data, if you clear your history, then try to bring it in again. Then you can now, or you save it as CSV. Then if you save it as CSV, you might not have that issue. But if you are importing as XLS, Excel spreadsheet, then you might need to check. There's a box that shows import the first row as a variable name. All right, thank you. So as I was saying, so describe it gives the general description of the data set and the format of each type. Now we can see from here all of the variables names we have. Then we can see the storage type. We can see the display format. Then we can also see the variable name. So that is what describe does. Now the next thing again we can also do is for us to get some basic descriptive statistics for each of our variables. All right, some basic descriptive statistics. In doing that, we can use the word summarize. Now, the word summarize is a command that gives basic descriptive statistic of each of the variables in a data set. And when they are using the summarize as code, so the summarize is the American summarize that has the ZE. And again, if you don't want to use the word summarize, you can also use sum, SUMM. All right. So when you use SUMM or use summarize, it's also going to give you the same output. So from the command line, you type in SUMM, you press in enter. All right. So you can now see for each of our variables, we can see the numbers of observation, we can see the mean, we can see the standard deviation, we can see the mean in terms of the value, then we can also see the maximum. All right. We can also see the maximum. All right. So the first one is you describe. The second one is you summarize. Then another thing you can also use in also exploring your data set is to use what we call code book. All right. Code book is also another command in STATA that shows you, okay, just type in code book altogether, then you press and enter. So it gives you the description of each of your variable, similar to what we have for summarize. But for here, you can see the type, you can see the range, you can also see the mean, the standard deviation. But here, the percentiles is also added. Then we can see the units. Then we can see if there are missing variables. All right. So you can also see the missing variables out of the total numbers of observation. Now for here, we have 0 of 499. So it means that the total variables that we have, the total observation that we have for these variables is 499. Out of each, we have 0 missing variables. All right. So this is also one important ways of also exploring our data. Now, another way of exploring our data is by using frequency. Okay, it's by using frequency. Now, if you want to use frequency, the command is tab, TAB, then the variable name. All right. So it's either you use TAB, variable name, or you use TA and the variable name. Note that when you have your tab, there's a space. Or if you don't want to go through the space, each time that you click on the variables at this point, then it's going to bring the variable to the command line. So let's say, for example, we want to tab gender. So we say TA, all right? Then I'm going to click on gender. Now we can see the arrow here. When I click on the arrow, it drops at the command line, then we press in enter. Then we can see, so gender is 1 and 2. Now we don't know what this 1 and 2 is because ideally there should be a code book. Okay, there should be a code book. But for now, this is an analysis which shows that 1, which of course might be male, and 2 might be female. So the numbers of frequency is 255. Then we can also see the percentage. We can also see the cumulative as well. All right. So when we are exploring data using frequency, with tab it. All right, we tab it using TA or TB. Again, you can use TA, TAB. Then we look at education again. Then we press enter. So we can see it still gives us the same thing. Either you use TA or you use TAB. All right, in exploring our data set. Now, another way of exploring our data set again is by using table. I don't know if we're following and we are taking notes. The difference between the command table and tab is that a table combines frequency and descriptive statistics. All right. Table it combines frequency and descriptive statistics. All right. Okay, excellent. So let's say, for example, I want to tap for for gender again. So it's going to be table. Then I'm going to bring in gender. So what makes this different is that we're now going to have an extension. All right. In terms of when we have the content that is actually of interest in what we need to do. All right. So in that sense, we're going to put a comma, content, okay, open bracket, the frequency in this manner, the mean, all right, the mean. Then you can also close this, for example, then we tab it. Oh, sorry, table, gender, content, and the mean. Okay, then I'm bringing another education, then the mean and the score. We close it. Variable, sorry. Then probably location. We're trying to combine. Then we have something like this. So we can see, so this is showing us the mean of education and also the mean of location with respect to gender. All right. So this is another way of exploring our data set the way we want it. Another way of exploring our data set is by using crosstab. So we're going to understand crosstab better when we are working with chi-square. All right. So another way of also cross-tabbing our data, of exploring our data is by using crosstab. Now, one thing you need to understand why using crosstab is that the data must follow must be nominal or must be a categorical data. All right. So if you want to exploit using a crosstab, then you need to ensure that the data is a categorical data, or that is a categorical variable or follows a normal distribution. Now, for example, gender is categorical, education is categorical, location is categorical because they have options. All right. So, and in doing a crosstab is a tab, the first variable and the second variables you want to crosstab. All right. Let's say, for example, we want to crosstab gender and education. Then I'm going to say tab. Then I'm going to bring in the first one. Then I'm going to bring in the second one. Then I'm going to press enter. So this crosstab. So we are crossstabbing gender by education. So this, of course, becomes a 2x3 table because we have 2 levels of gender, then we have 3 levels of education. Now, another thing we can do, each time we're working within a STATA environment and we need to give an options, all right, to your command, then we use a comma. All right. In doing that, then we can have maybe we're interested in the column total. All right. Then we have this. So this is giving us the column total because of the COL that we have here. If our interest lies in the row total, then we change this column to row. I don't know if we are following. So we can now see that the total is by the row. That is why we have the total 100 here. But if you look at the previous one, the crosstab total is by the column. That is why the total here is by 100, 100, 100, all right? So the importance of row or column depending on how you are going to describe or interpret your data set. I don't know if this is clear. Any questions any clarifications before we proceed? Any question? Okay, none. Okay, clear, excellent. Yeah, most of us, we are actually an expert already. All right, so let's proceed. So the next thing, one of our focus again, we need to do today is what we call renaming variables. So at times, when you collect the data from the field, or you design your questionnaire using Kobo Collect or Survey-CTO, and when you download your data from the cloud from Kobo Collect or Comcare or what have you, and you now need to upload the CSV into STATA, there might some of the variables in such a way that it might becomes clear to you. For example, some variable name can come in as Q14. Q14 means question 14, all right? So probably when the data was collected from the field, the variable was named Q14, which means question 14. But for sake of understanding and analysis, there might be need for you to rename your data. The variable. So in renaming your variable, the code is just rename the old name, then the new name. Are we together now? In renaming, I want to believe that we are taking notes by the side. So is the rename, so the rename is the code, then the old name, then the new name. Let's say, for example, that we want to rename age, for example. So age becomes rename. Age becomes rename. All right, rename. Then we bring in the old name because this is old name. Then the new name might becomes a capital letter. Small letter A in lowercase. Now you can see the difference. The old name is capital letter A in terms of the uppercase, but we are renaming this to becomes all in lowercase. When that is done, then we can tap it. Now you can see that that has changed. I don't know if you noticed that it has changed. All right. We can also do same for education. Education here in terms of the variable name is capital letter. For the uppercase is E. Then we can make it a lowercase, rename. All right. So you don't need to retype the old name, rename. Rename. Then you bring in the education here. Remember, this is capital A. Then the new name becomes education in terms of a lowercase or whatever you want to call it. Then that's it. You can see that that has changed at this point. So these are ways by which you can rename your variable. Then another way also is label. Now labeling is very important because it gives a comprehensive explanation to your variable name. All right. So when you just say gender, but with your variable name, it gives more explanation to your variable names, and it also allows for spacing and special character and what have you. Now in doing that, we have label, okay, the variable, then we bring it probably education. That's variable we want to label. All right. Then space, then we bring in quotes. Then I can call this education, or say respondents educational level. Then I close it. Does that sound clear? Then I tap it. Now you can see that at this point that this has changed. Look at this. This has changed. Look at this. All right. So when I click this, then you can see the detail at the property window. All right. This education, and this is also the label. All right. If I change it again, other than retyping the code, I'll come to the review window. I click this again. I can just delete. I can delete respondents, for example. I'm reusing the code line. Then I change it to capital E. Then I enter it. Then you can see again that it has changed. So this is one of the importance of the review window, because it helps you to reuse variables, and all of the variable that you've used successfully, you can also select them and also push them to do far. So that is one thing also that we're going to do today. So I hope you understand how to rename variables, and we know the importance of renaming. There's some data set you collect from the field. I'm sure, we must have been involved in some of them, that the variable names comes as Q1, Q4, Q means question 1, question 4, and all of that. But doing analysis, it's very important that you rename those variables in such a way that, it's understanding, is passing an understanding to whoever is actually going to run the analysis. Then another one also is for us to be able to label, to give an adequate information to our variable name by the label. All right. So in doing that, we just use the word, the code line, label space variable. We bring in and the variable name, then the text. All right. So the text that we are naming the variable has to be in quotes, just like what we have at this level. Okay. This code line that is highlighted. All right. So that is renaming variable, adding variable name, and we can also change it as much as possible. All right, let me move on here again by trying to assign value labels. All right, assigning value labels. Now, if we tab gender, for example, tab lowercase gender. So we have gender as 1 and 2, but 1 and 2 does not, we don't really understand what is 1 and 2. Is 1 female? Is 2 male? Or what have you? But of course, when you're conducting a study, when you're having your coding, then there's also what we call the code book. So code book gives an explanation to how you've assigned values, or how you've assigned numeric values to your variables. All right. For example, you have education 1, 1, 2, 3. You have gender 1, 2. You have location 1, 2. So 1 could be rural, and the 2 could be urban. In doing that, so what we need to do is that we need to use a code that is called label define. All right, label define in assigning value to labels. Okay, assigning value to labels. So we use label space define. Define. So sorry, define. Then we bring in gender. All right, value define. So we bring in gender. Then we say 1. Okay. Sorry, 1. Quotes of male. All right. We close it. Then we say 2 quotes. We say female. Then we quote it. Then enter. So when that is done, the next thing we now need to do is to and give the value in terms of now we have the gender back to the 1 and 2. So we now have it as label values. So the first one is gender, then the gender that we've labeled here. All right, we bring in it again, gender. Then if we tap gender again, then we've actually assigned that. Then we say enter. Then we have it in that manner. Same applicable if we look at education also. Education is 1, 2, 3. Then we might also want to assign value to it. Then we'll go through the same route again, label, define. Then we'll bring in our education. All right. So 1 in quotes is primary, 2 secondary, quote, 3 tertiary. All right. Then enter. Then label values. So we have education, education. So if we tap this again, all right, then we can see same. All right. So what we just done is we are assigning values to label. It's very important that when data are collected from the field, they comes in numeric value. All right, it comes in numeric value. Then you need to now work by your code book in order to update this. Remember, during our statistics, doing our SPSS class, in the view, in the variable view, I think in the data view, there is what we call label, where we define our variables. You remember when we say 1 is male, 1 is female, and 2 is female. So the same thing, and that is what we are doing here in STATA when we are assigning values to labels. All right. So it is important. It is at times when you collect data from the field, it comes that 1, 2, 3, 1, 2, 3, 4, 5, and what have you. So doing analysis, you need to assign those values from your code book before the analysis. And that is actually what we are doing here. All right. We are assigning values to label. All right. These are the steps you take, and you explore your data, using different commands, describe, summarize, you explore using crosstab, using frequency, using tab, using table. Then after that, you now have, okay, you can also rename your variables. After renaming your variables, you can also define your variable labels. Then afterward, you assign values to your labels. I want to believe that we are following. All right, and that is very clear. Now, another thing again that is also important is recording variables. Hello, recording variables. Now, let's say, for example, when we design questionnaire, there are two types of questionnaire. We have the close-ended and we have the open-ended questionnaire. All right. We have we have the open-ended questionnaire. Then we have the close-ended questionnaire. Let's say, for example, in a questionnaire that says, what is your age? What is your age? When you leave the question open, okay, that is an example of an open type of questionnaire, which implies your respondent can say 10, 20, 14, 15. It becomes a continuous variable. All right. But in the case when you say, what is your age? 10 to 14, 15 to 19, 20 to 24, that is an example of a close type of questionnaire where your respondent can only respond within a closed options, okay, within a closed option of 10 to 14, 15 to 19, and 20 to 24. But when you have it open, that is when your respondent can say, I'm 20, I'm 14, then that becomes a continuous variable. Now, in an example that we have here for the variable age here, when you tap age, all right, when you type age, all right, this is a continuous variable from age 14, excuse me, from age 14 to 49. All right, from age 14 to 49. This is a continuous variable. Now, when continuous variable in terms of age is good when you want to calculate your mean. So oftentimes when I'm collecting, when I'm conducting a study, I always love it to have my age variable to be open so that I can calculate my mean and also calculate some other statistics. Then after which I can recode my variable, all right, into categorical variable, all right, that can now make it 10 to 14. Now in category and in recording your variable, what you need to know is that what is the lower class, okay, and the upper class, or the lower limit and the upper class. Now, in this case, we have 14 as the lower limits, and again, we have 49 as our upper limit, as our upper class. So instead to use the code that called recode, all right, recode. There are two ways. There are two ways of recording variables, and I'm going to show us the two ways, all right? There are two ways of recording variables. The first one is by using the code word record, all right? Then I can say the lower is 14. Then I can say 14 to 19. Sorry, record age. Okay, record age. All right. 14 to 19 equals 1. 20 to 24 equals 2. 25 to 29 equals 3. 30 to 34 equals 4. 35 to 39 equals 5. 40 to 44 equals 6. 45 to 49, okay, equals 7. So when that is done, we now need to generate a new variable that we are recording the variable age into, all right? So we need to generate a new variable, so okay, that we are recording the variable age to. So in so doing, you can use the word gen, gen, or you write it in full, generate. But most times you can just use gen, gen. Then the new variables can now become age, age or age recut, all right? Then you close it. Remember, you can use the full word generate, or you use gen, all right? So when that is done, you say enter. 99 observation, all right? We have it between the age and the age record that we created. Then the next thing we need to do, all right? The next thing we need to do is for us to label define. Now, if you tap this, all right, let's tap this, tab. Okay, so we've tapped what we've created. So this is a new variable we've created. It's 1, 2, 3, 4, 5, 6, 7. But we need to label, we need to define the variables in the way we've created this. So we are not yet done. So the next step we need to do is to label define. We need to label define the new variables. We need to label define okay. So label define age cats. So we can have it as a 1 becomes excuse me 14 to 19, all right. 2, 20 to 24, 3, 25 to 29, 4,
Prof.
30 to 34, 5. Say that again. 5,
I think
35
it should be
to
label define age records, not age cards. Are we not label? Is it not
okay.
the new variable
Thanks.
just
Thanks.
created?
Yeah. Yeah. Yes. 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 That's it. Yes, you are correct. It's age records. Thanks. Thank you for bringing that. Yes. So 35 to 39. Then 6 is 40. 40 to 44. Then 7 is 45 to 49. All right. So with that, label values, age recap, age recap. So we can now tab it. That's it. Are we following or it becoming It's becoming too long. Can somebody talk to me? So one thing again that we need to do.
We are following.
Okay. Excellent. Thank you very much. All right. So one thing again, if you don't want to, like I said, that we are going to get to, so we can actually keep all of these variables starting from these points. All right. So you select the first one, then you press down your control key. So you select those ones that you ran successfully without the one in red. All right. You select them manually because of those ones that, or you can select all, then you remove those ones that when this is selected, then send selected to do file. All right, send selected to do file. Then you click on that. Please, can you see the do file window that opened? Hello?
Yes, Prof. We can see it.
Yeah. So yeah, so this is the do file. So for all of the analysis we've done, it is actually in all of these do file. So with this do file, I can rerun all of the analysis from the beginning to the end, which means that I can send the data set to anyone in the world, then attach my do file to that person. So with this do file, the person can, and even with this do file, notes. In doing that, for example, you have to use hash, then you can say descriptive analysis, then you close it. So with this, you can also give description of each of your code line. Then I can have this saved. Again, sample use, I can have it saved as my do file for reuse, okay? So we come back to that just for it so that I have all of this saved, then I can actually use them in the future. So that is that with recording variables, all right? So another ways that we can also, okay, I think that's fine. So not to bug us. Then another way again that we can also run this analysis, I mean, there's just lots of them. So when we tab, we can say tab hcat, comma, no label. So we have this. Now, there's other way we can also use command in STATA, for example. I can say tab hcat if hcat equals to, so the equals to, it becomes double, it comes to 1 or 2. For example, I think I'm still correct. Then we tap this. So what is not there? So we have, okay, I think we can come back to this. I need to check my code. Okay, if it's got to 1, then we can have that. If hcat is 1, okay, that's in value. My code is 1. Okay, but that's fine. So we can get back to that. So I'm just trying to use the if option for us to understand what can be done in that sense. Then again, we can also use what we call replace. Okay, replace. I'm just trying to see how we can explore our data set, replace. Now, if we tab gender, for example, gender, we can see that gender is, the option is male and female. But of course, you might want to replace your gender probably to be I mean your male to be M and your female to be F. So in that sense, we are going to use the code word called replace. Code, I mean, that we are talking about, but I think if you study these things step by step gradually, you are going to get it. So we can use the and the code word called replace, a variable name, gender, okay, equality sign, and codes, hem, okay, if, and that's the condition I was trying to put the other time, if gender equality sign into time equals male, then we enter it, mismatch. Why? Replace gender if gender, is it a space? Mismatched. So what can help out? Why is it that? Or probably, okay, replace replace gender equals to this. So I don't know why it's giving this error. Can somebody explain why we have this error? Anyone? Anyone? Okay, so I need to check why that error is coming up. Why using replace gender M if gender is this. Yeah, but this is correct. Replace gender. Data merging. We need to have two data sets. All right. So there are two types. We have what we call merging, and we also have what we call appending. So when we merge, we are adding to the variable downward. No, sorry, no. Okay. When we merge is for example when we have ABC. Oh my God, I don't know how I can explain this with an example. Just hold on. So when we merge variable, okay, so when we merge is when we have, for example, in the first data, we have variable ABC. Now in the second data, we have variable ABCDE. Okay, remember in the first data set, we have a variable C, all right? In the second data set, we now have variable ABCDE. Now, when you merge the data set, now the data set is going to add variable DE to the data sets. All right, so which means that the first one has ABC, the second one has ABC, but in addition to DE. So when you are merging, So you merge. So when you merge, those ABC becomes becomes, because you already have those data in the second variable. So it's only going to pick the DE variables and merge it together. But when you append, you have the same variable name. Probably you have a variable, but the numbers you have might be up to 10. But for the other second variables, you have more than 10 observations. So when you append, it continues underneath. So please, what we are going to do today, I don't have variables. I don't have data set for us to be able to explain that. So what we are going to do is that tomorrow, I'm going to find a data set that we can actually use to get this done. Okay, there's a message in the box. Okay, somebody said replace gender. Okay, let me try that because I think that was similar to what I did initially. So it's still the same thing. All right, so never mind. So I'm going to find out Usman to know where the issue is. All right, so that is that. So thank you very much. So let me proceed again by running some graphics. All right. So what we are going to do today, like I said, we'll do some graphics, we'll do some descriptive statistics which we've done before, then we'll do some inferential statistics, or probably we are going to stop today in running some graphs. All right. So I think time has been spent already, so that we don't, so that we can digest all of this. I can share the data set with everyone. I mean, I'm going to share the data set with and Dr. Benga. Then he can share the data set and the code book with everyone as well, so that we can also and run through the do file for better understanding. All right, so let me proceed. So some of the graphs that we can run, like I said, we can go through the menu in graphics, and we can also go through the command line in terms of the command window in doing what we need to do. So one of the charts we can also run is histogram. Now, when you're running an histogram, your data has to be continuous. So example, our age here is continuous, our weight here is continuous, and as an example of what we can do. So in doing that, we can use the word histogram. All right, then we can say age, then enter. So at this point, we can see here that this is running. Can we see the histogram, everyone? Please, can somebody confirm if you can see the graph window?
Yes, sir.
Yes, yes.
Okay, good. Okay, good. Now, I think it's also going to work. Let me just try that out. Is, then age. Okay, it's not going to work. So I thought it's going to, I think is EST. Let me try. I think I've done EST age. Okay, this also work. All right. Okay, so this is it. All right. So which implies that you can actually write the word histogram in full, or you use HIST, H-I-S-T-H. Now, when we run this, it's actually showing the density. Now, when our interest lies in the in frequency, all right, I'm picking the code again. Then we put a comma because we're giving it an option. Then we put in frequency. Frequency. All right, we need to be okay. So the spelling of frequency is wrong, and that is why it's giving me an error there. Frequency. All right, that is that. Then we have this. So this is showing frequency instead of density that showed initially. All right. So another thing we can do with histogram. Now, histogram is one of the graphical method of testing for normality. All right. Remember, I said to us that when we want to check if our data set follows a normal distribution, I mean, if we want to check if we are to use a parametric or not parametric test, then we need to run a normality test. All right. and then histogram, QQ plots, PP plots, box plots, these are examples of graphical method of testing for normality. All right. So we can actually use to also test for normality, like I said. Then in so doing, I'm still going to bring back my code. I'm reusing the code other than typing it again. Okay, east age comma frequency. Then I'm going to add another option that says normal. So never mind. I'm going to share this code book with everyone. Then you can study the code line for better understanding. So I'm going to put east age comma frequency, then normal. Then we have this. So this, for example, does it follow a normal distribution from this? Okay, I'm not going to answer that because when we come to that, then we can talk about it more in detail when we are talking about parametric tests. When we're talking about inferential tests, which we might not get to do today. All right, so this curve, is a bell curve. Okay, so we are like it's, yeah, that's correct. I think yeah. So this looks like, yeah, because of the bell curve. All right. So, but again, we're going to look at that in detail in our subsequent class. So another type of graph that I've loved to use in the past is what we call the cat plots. Again, there are ways of installing new program in STATA. All right, we're going to get to that gradually. Now, it is possible that because I have used catplot before, that is available on my STATA, but if it's not available, then I have to install it all over again. Now, let's say, for example, I want to run cat plots bar, then I have education over my age category. All right, over my age category. Then I want this in the B bar. Let's see. Okay, so you can see that it's telling me that my cat's plots is not recognized because probably I've not installed it before or used it before. So in installing that, so there's a command line, just note it. It's a gradual thing you get to understand. We use xxc install cat plots. Now, let me say this to you. If you need to install this, you need to be connected to the internet. Now, if you don't want to go through this route of this command, you can actually use help cat plots. All right, you press enter, then it's going to bring up the help. Okay. Please confirm if you can see the help window.
Yes,
Please confirm if you can see
it.
that. Okay, so from here, if you click on the, sorry, do you see you can see it?
Yes.
Okay, so from here, you can actually click on cat's plot from here. Okay, you click from here. So when you click, then you can also install from here. All right, so those are the another option. Then I can click install. Then it's checking the cat plot consistency and what have you. Then you can see the message installation complete. So that is one way of installing cat plot. But if you don't want to go through that route, you can use the SSC install cat plot. All right, but I'm not going to do that because already I've installed that going through the help. All right, help, then cat plot. So now that I've installed cat plot, I'm going to bring out this my code line that was error initially. Then I'm going to enter. Okay, it's telling me the bar not found. Why? I do not know. Okay, so let's see if
I
there's
think
a way I
it has to do
can.
with the first bar.
Yeah, so that's my thought. Okay, somebody say, okay, cats. Okay, thank you. This works. Okay, let me try that out. Thank you very much. So you can say I told you okay, let's see this. Okay, no, sorry. Okay, I need to change what I have here. Oh, education. Okay, excellent. So this works. Okay, and so I think okay, the issue why the other bar was there is that instead of having it in this manner, I would have wanted to be on the y-axis. Is it y-axis now? The x-axis. You get the point. So that is why that is what this bar is doing there. Yeah, so that's why this bar is doing there, so that we can have the other one the other way around. All right, but it's something that I can actually check in detail. So thank you, Ibitoye, for that. So I think so that is that. So for the frequency again, we can okay. So that is that. So I think some other ones. So I'm sure it's going to be about some of the stuff that has not been installed in there. So, but if we have this graph, H bar, H, okay, variable names is important. Okay, so this is just some of the code that we need to look at it closely. And then what are view? So I think this is where we are going to stop today because of our time, so that we can also digest this. So what we're going to do our next contact is that we are going to look at normality test. All right, so why normality test is important, so that we can check if our variable follows a normal distribution or not, so that we can know the appropriate inferential statistics for us to use. Probably we are going to use a parametric test, or we are going to use a non-parametric statistics, bearing in mind our understanding with scale of measurement. All right, so two things: we need to check the normality test, if it follows a normal distribution or not. Then also bearing in mind our scale of measurement, if it's nominal, if it's scale or ordinal. But what we have able to be able to do today is around data management, exploring our data set and descriptive analysis, graphs, and then what have you. So what I would just implore us to do is that we need to work more around this data environment for us to have better understanding and then what have you. So I think it would be great for us to stop here. So I want to thank people that joined. I know that some of us were already an expert in STATA or an intermediate, but of course we have some folks that are newly joined us. So that is why we need to take it gradually, and I thanks folks that are also chipping in support. And at this point, I'm going to stop to take questions or any clarification for today. Then we can proceed accordingly in our next class. So in our next class, we're going to review the appending and merging. All right, so I'm going to get two data sets that we're going to use. So we're going to focus on appending, merging and appending. Then afterward, we're going to look at normality tests. So we're going to look at two types of how to test normality in terms of using a graphical method and also using statistical method. All right, so that can tell us if we are going to use parametric tests or not parametric tests, the Kuskawalis, how you test and what have you, so that from normality test tell us the appropriate statistics for us to be able to do for our analysis. So at this point, I'm going to stop here and allow Dr. Benga to coordinate for question and answer or any clarification or any addition, or as the case might be. And again, let me also say that don't be afraid to make mistakes, all right? You can, like I said, when you're typing in your command line, it's case sensitive. So at times when you need to type in lowercase, you type in uppercase, you get a red flag, all right? So when you get a red flag, you just correct it. Even an expert code error, all right? It could be when you need to put a comma and you forgot to put a comma, then get a red flag, all right? Then you just need to check it again. So, all right? So when you're walking around STATA, don't be afraid to get a red, all right? So you just need, and then you move on with it. So on this note, I'm going to stop here, then allow Dr. Benga to coordinate question and answer. Thank you and good evening.
Yeah, thank you so much, Prof, for that very clear session. Please confirm that you can hear me loud and clear. I'm not sure, I can't trust my internet like this, but
I can hear you.
oh, excellent, sir. So for anyone that has a question, please, you can raise your hand so that we can take your question. But I have the first question for Prof. So, Prof, I'm not trying to put you on the spot, but the obvious truth is that this contact will not go forever. This contact will end when it's supposed to end. You are giving us a lot of foundational learning. So, but some of us have actually watched you, apart from us working with STATA every now and then. Which other way can we gain new skills on the use of STATA, apart from using it for deal analysis? For example, is there a community that one needs to belong to for STATA, where you will get update of new things about STATA? I know that everyone here might want to know that. Did you lose me, sir? The question again. Oh, okay. I think we lost. Okay, it's coming back. Okay, Prof, you disconnected.
He's in now. He's not disconnected.
Yeah.
Mhm.
Okay, so I just found another way to, you can, so when you click on this sort, so all of those error can actually, you can have them piled up, so that when you are bringing in your stuff, Dr. Binga, please go ahead.
I think we can stop the recording as well.
Yes, so is the one, so can I, so it's from, the recording is from his end. I think I don't have control over it here, do I? Yeah, so Binga, please, can you stop recording? So I think his network is not great, so I think we are actually good. So please, any comment from anyone, any contribution before we call it a day? Contribution?
I actually want to say something.
Yes.
Concerning the codes, how do we keep tabs on them to be able to use them more and more? Because they are really much, so I don't know how I can know.
So I think it's continuous practice. And some of these codes are just something like tap, 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 you know, it's something when you want to, so it's, I think it's continuous use. And then there's a slide that we can also share out that can give you some idea of all of these code, you know, for you to be able to practice with. But again, it's just the more you use it, you know, the better you become. So I don't know if John or Dr. Dede can also advise on now best.
Well, I think there's really no alternative to just keep trying and making the mistakes and learning through it, I guess.
Exactly. So the more you use, the better you become, I tell you. So I'm sharing the do file with us now. So any other comments before we call it a day? So please try, you need to update the directory, all right? Okay, from where you are importing from. So okay, so I think Binga is no longer here. We might need to end it here. Or what do you guys think?
The meeting is still in. It's just that it's typing.
Okay, type in.
Yeah.
I was
He's responding
Okay,
to
so let's just wait
somebody.
for that.
yeah. Okay. Prof, can you hear me?
So quick one. If we need to open the do file, for example, so we can just come to same file, and then when you come to open, all right, then you can change your file. Okay, open. Then we can change the file type to do file at this point. All right. Then you locate where you save that from. Alternatively, This is the icon for do file. Okay, new do file. Okay, you can see that new do file. So when you click it, you can. This was the last one I used. Then you can click it. Then it comes up. Or if it opens, then you can see open a new one. You can see the open icon. Then you have it there. Now in running this, for example, just put your cursor at the beginning. All right. Then you can see this icon that say execute do. So when you click on everything, or probably you want to run a section of the command, you just highlight that section only. All right. When you highlight that section only, you just click on this icon, then everything will just run automatically. All right. Please let's know that. But it's important that this line 3, you need to update this directory to your own directory where you save your data. All right, it's important because if you run this now, it's not going to work because this is my personal directory. So that's why I put a note here. Please update it. So you need to update this. Otherwise, when you try to run it, it's not going to work. Okay, this line 2 and 3. Okay, line 3 and 4, that needs to be updated. Please
How
confirm
do
you
we
can
do
still hear
that?
me. Huh?
How do we update it?
Okay. Now, for example, if you need to update that, okay. So, okay, let me go to, just hold on. Okay, sorry, I need to find a sample. Okay, this is it. Okay, so let me share my screen and stop this. Okay, so this is the sample data set that I've been working with. So if I need to get the directory for this to update this, I'll come to file. You can see the directory. Can you see that? Yeah, so this is the
Yes.
directory for this. So which implies that at this point, so which implies that okay, so which implies that whatever you copied at that point, you need to use that to update these parts up to this point. Does that make sense? Hello?
We are with
Hello?
you.
Yeah, because for example, now these users could be your name or whatever you used to save it. So, but when you go through, so from this C, all right, from this C to this XLS, all right. So when you open the Excel or whatever, then where are you? Then you can easily pick it from here. So if you check your data set, for example, so just click on when you are in home, go to home, then come to info, then this in information, then can easily copy this and use it to update in that other place. Then there's also one thing that I also need to mention, okay? So when you're running your analysis in STATA, we're also going to talk about that tomorrow in the next section. It is important that from file, it is important that from file, you need to begin your log. This is very important. So this your log also saves your code and also your output. Now, there are some MPH classes. You know, when you're running an MPH class, you might be asked that you should submit your log outputs. All right. So your log output shows your code line and also shows your output. All right. So when you have all of that saved in here, okay. So we're going to touch base on that in our next contact. So before you start your analysis, the first thing you need to do is to open a log. All right. So we're going to talk that in detail in our next contact. So when you are done with your analysis, you can close it. You can see close. You can suspend it while you are doing some trial. Then when you are done, you can resume it, you know, and all of your code line and output, it's saved, other than trying to export your output, but you have that all saved in your log. Then you can open your log as a Word document, you know, depending on how you've done that, and we can have that. So just to also mention that very quickly. So I think at this point, there is no any other question. What's the question? Can you share your data and let us know? Okay, yeah, thank you. So Mr. Suleiman, do you want to share your data? Can you share your data and let us know what type of analysis you want to do so that we can work it out together? Okay, that's fine. Okay, yeah, that sounds good. So I think on this note, time has already been well spent. So I'm just going to take some last few inputs, contribution, then we call it a day. Any last word? Dr. Binga, can you still speak? Can you stop recording, Dr. Binga?